Hey guys, I'm Vanderson from MedLab VFX here. Welcome to the complete course of creating this burning pirate flag effect from scratch. We are going to break down every step, from simulation to shading and final rendering. Let's get started. Let's create a subnet, rename to pirate flag, change the color to purple. Let's dive inside this node, create a geometry node, rename to geo preparation. Let's dive inside the node, create a grid, change the orientation to XY plane. The size should be 4 by 2. Rows and columns change to 2. Create a match size node. Here in justify Y, change to minimum, just to align the bottom of the flag with the ground. Create a group here, rename the group flag. Let's create a name attribute and change the name to flag to organize the look dev. Let's create like a metal support here at the side. Create a tube. Move this tube to here, this side. Increase the height, lower, and change the radius scale to a small value like this. Like this should be okay. Create a merge node and create a sphere. The sphere should be at the top of this tube here. Let's move there. Okay, scale the size. Don't need to be so big. I think the size is okay. Okay, the size is enough. Create another group here. Name this to group metal. Create a name. And name here to metal. Create a merge node. Merge the flag and the metal. And create a checkpoint here. Alt flag. Change the color to black. Create a geometry node. Change the color to green. And rename to Vellum flag. Vellum. Let's dive inside this node. Create an object merge. Just to merge our flag here in this node. Alt flag. Let's create a blast node. Just to keep the cloth part. We don't need the metal part for the simulation. Keep flag. Change it here to group flag and delete non-selected. Okay. Let's create a resample here. To add more points at its edges, like 0, 2 in the length. Create a mountain because I don't want the flag to be just a straight cloth. I want to add some noise at each edges, both from bottom and up edges. Let's do that. Create a mountain. Change the amplitude to 0.1. Disable here noise along vector. Let's change the output to 0. We don't want the noise in axis. Let's disable this a little bit. We don't need the noise in the axis Z, just in the Y. Okay, this is enough. Let's create a remesh. The remesh value here should be around 0 to 5. Okay, let's create a rest node and create here a noise, another noise, attribute noise. Change here to position. That's okay. For creating the fracture in the cloth, to make the tearing in the cloth, we need to create this node cluster. Connect to this point here. Let's create some scatter points, like 10 points here, and connecting the cluster. Let's promote an attribute here, just a visualization. We need to promote this attribute here, the cluster, for primitives. Cluster from points to primitive. Let's preview the cluster attributes in the primitive. Random from attribute cluster. The attribute promote here, we need to promote the promotion method should be maximum to avoid these weird edges here in the promotion, in the edges. We need to make it maximum and create another scatter here to make more points, around 100 points, and merge these two scatter points here and connect to the cluster and see the result. Okay, let's create another REST node here just to make the points going the original position here, like this. Here in the REST, we need to change the mode to extract REST. Okay, let's create a primitive split, because if you want to see the exploded view of these fragments, these parts here, it's not possible because the geometry is just connected. To separate this piece by the color, we need to create this primitive split here and separate by the cluster, not the name. Now you can see the explosion by each cluster information here. Like this. Each cluster is a separate piece. Let's disable the explode view nodes. Let's organize this node first. Okay. Let's move this up. Okay. Let's create a group. We need to create now a group of at this side to fix the points of the simulation, of the Vellum simulation. We don't want all the flag should be animated. We need just to fix these points here. We need to rename this to group pin, disable the base group, and enable the bound box. The bound box should be in group of type points. Move this box here, move this up. Let's see with the metal support here. Around here. Okay, this is enough. That's the point should be fixed in the Vellum simulation here. Let's create a cloth. Vellum configure cloth. Move this here. We need to create a Vellum glue to glue off all these parts here. In the Vellum cloth, change here the pinpoints to group pin. In the Vellum glue, we need to change some parameters here. To make the Vellum stronger, we need to change here the constraint per points by 10. Search preference the fastest. Okay. Let's put this in the solver and see what's happened. Vellum solver. Let's organize here, delete some attributes we don't need. Delete attribute, delete. Delete everything. Delete some groups too. We don't need any group here. And create a file cache. Rename this to cache. Flag Vellum. Change the frame range here 1 to 200 and change the FPS to 30. Change again the end frame to 200 because we changed the FPS first later. Okay, let's save this and see what is happening. That's the result of the simulation. The result is not okay because we need to create the first we need to create the velocity field that should be drive the velocity of the flag. Okay, in the Vellum solver, adjust here the force gravity to -2. -2 is enough. Disable the built-in wind. And here in advanced, enable the multipass solve. Let's create the simulation again and see what is happening, because we need to create the velocity field to drive the movement of this cloth, the flag. That's the result. The gravity is much better. Now we need to create the velocity field. Let's create a bound. Connect to group pin and increase the size of the bounds, like 1 in the lower padding, X and Z, upper padding 1, E1 here, and Y2. All the values should be the same. For avoid to change all the values manually, let's copy the parameter and paste relative reference. Paste just the expression here. Should be easy, for example, if you want to increase the value here for 1.5. But we don't need too high value like this. Just one is enough. Let's create a VDB from polygons to scatter some points here. Change the foggy VDB to density. Create scatter points around the 50,000 points. Disable the relax iterations and create a point velocity here. In the velocity, enable the add velocity. Change the x to -1 and the y to 0.5. In the basic, just change here to keep incoming. The curl noise, add curl noise, scale by 2. Change the offset to -$t. Change the y offset to $t times 0.5. If you want to see the velocity field, you can use this node here. First, we need to rasterize this node to VDB. Volume rasterize attributes. Change the attributes to V. Create a checkpoint here. Change the name to ref velocity. Create another bound just to visualize the velocity field. Another bound from here. Create a points from volume. And create a velocity trail. Volume trail, sorry. Connect the points from volume here and the velocity in the second input. Create a checkpoint. Rename this to ref velocity preview. That's the previsualization of the velocity field. Change the trail length. You can see here how the velocity is working. Is working from the right to the left, and the down from to the up. Just to keep the flag moving. Inside the Vellum solver, let's add some motion here. Create a pop force. Connect to the force here. Change the amplitude to 4. Surreal size to 0.3. Pulse length to make slower like 10. And the offset change to $t. This $t variable is grabbing the timeline, the time of seconds elapsed in the timeline. For example, here in the 30, we are using the FPS 30. At the frame 30 should be 1 here. Amounts to 1. Let's create a pop. Add vector by volumes. Change the field name to V. Select the SOP to the velocity ref velocity here. Change the active action method to trace arc4. That's it. Let's save the simulation and see what is happening. The simulation is working, but I think we need to change some values here in the cloth to bend, because the bend I think is too strong. we need to reduce the strength of the bend. Let's change the value here. Change the stiffness of the bend to the smallest value here. And cache again. That's the result of the simulation. Now it's working cool. Now we need to activate each piece here, like where the fire is growing. For example, we need to make a mask animation to decide where the fire is working, where the fire is starting, where the pieces are detaching from the flag. Let's do that. Let's organize here. Let's move this here. To make the pieces detach from the flag, we need to create a rest here, rest position. Actually, the first output, create a noise, attribute noise, give some space here, change the attribute's name to position, and that's it. We don't need to change any parameters. Let's scatter some points around 12 points. Create a clip node, because at the flag here we don't need to spreading fire at this location here. We need to spreading fire from this location here instead of the near of the metal. We are using the clip just to clip. If you have some points here, we need to clip the spreading fire not to occur near of the metal. Change here, move the clip and change here the primitive below the plane. The clip we are going to adjust later. Let's create a color. Color for the points should be red. Create another color. For the flag should be black. Let's change the background here just to see the movement of the mask. Create attribute transfer. Connect the flag in the first input, in the points at the second input. Change here the attribute transfer just to CD. CD is just an expression for the color. Here at the distance, reduce the distance a lot, like around 0. And create some animation here. At the first frame, create a channel, set keyframe, and around the frame 150, increase a little bit the distance, around here. The mask is growing, but we need to create a rest position here, just to restore the position of the points. In the rest, change the mode to extract, and let's see the mask is growing. That's the location of the spreading fire, where the spreading fire start at the mask, at the flag. We can change here the seed if you want to see different formations here. For example, here we can change the seed to a different value to make the spreading fire change, and the detaching pieces you will change as well. Let's create a VFX node here. Pointer angle to create an attribute based on the red color to activate the piece where will be detaching from the flag. Rename the VFX to VFX stitch, remove, and put a little line of code here. If at cd.r, which is red, greater than 0, we are going to create these attributes at stitch underline remove equals 1, and change the color just to visualization. At cd equals set 1, 1 and 0. Okay, we have created this attribute here, stitch remove. What is this stitch remove attribute doing in the simulation? This stitch remove attribute, we are going to delete the glow constraint from the simulation, from the Vellum simulations. To create that, we need to dive inside the solver. In the source, we need to create a Vellum constraint properties to change and break the constraint, the glow constraint from the flag. Connect this here, enable the group, and change it to group to at type equals stitch. Here in the remove, we enable remove and change the value to 0. Here in the VFX expression, we are going to create a little line here. But first, we need to enable the stitch parameters from this node here. Actually, we need to create a checkpoint here. Change the checkpoint to ref stitch to remove. Let's go inside again in the Vellum solver and input 3, change it to SOP, and grab that node stitch to remove, okay, which is this node here. We are going to detach the piece based on that red mask by writing some VFX code here. Let's grab the remove attributes from each point to removing equals, let's give some space here, point 2, input 2, the attribute should be stitch underline remove for each point. If to remove equals 1, we are going to activate this remove attribute here to remove the constraint. Remove equals 1. Okay. Let's save the simulation again and see what is happening. Let's change the background to black to see better. I think the simulation is working with the activation pieces where we are going to spreading fire from the flag. The simulation is working cool. Let's make some adjustment here because we need to map our skeleton texture and make some post-processing here in the Vellum. Here we need to create some VFX here just to copy the color points here, transfer to this geometry here. To do that, we created this wrangle, change the name to VFX, copy color, and here just type @cd equals point first input, which is 0, 1 actually, cd for each point at pt none. And you're just copying the position, the spreading fire locations here. Let's change the background to the light again, sorry. And we can see here where we are going to be spreading fire and make the pieces. Now we are going to apply the texture to the original geometry, which is that geometry here. Let's create a UV texture and move this down here. Let's see if the texture is correctly applied. UVs. We're going to apply the z-axis, okay? Let's see the UV quick shade, just to see the texture. UV quick shade. Let's check with the texture of the skeleton, which is this texture here, part flag. Okay, let's delete the color from the primitives. Attribute delete, we don't need the colors. Just to see the skeleton, okay. Now let's copy the position. To apply the position of this simulation here to the texturing flag here. Create a pointer angle, connect the first input to the rest flag and the animated flag. Rename this to Vex, copy position. Copy position. And the expression here should be at p equals point one input, just the position for each point at pt9, and we have copied just the position here. We have seen here just like the detaching before actually detaching the piece. We can see a small gap here. We can do that. We can solve that by doing a little fuzz with a increase a little value here. With the fuzz, we can weld the vertex here and solve the problem. Okay, actually can increase a little bit the fuzz by 0.5. Okay, let's create a Vellum post processor here. Let's disable the quick shade just to see the geometry without any texture. Vellum post process. Enable the subdivision loop. Okay. Recreate the normals. Let's delete some attributes we don't need. We should keep just the M. Here at the normals, change to points. Keep the normals primitive here, normals attribute, and keep the UVs. Actually, need to enable this over here, and should be keep the UVs, and delete other attributes. Let's delete all the groups we don't need. Some groups here we don't need anymore. For example, the group pin, we don't need anymore this group. remove this group. And make the final cache just for the cloth simulation, the flag simulation. Rename this to cache, flag, simulation. And create the cache. Okay, let's create a trail node, just compute velocity. Rename to compute vel. Change here to compute velocity. Enable evaluate within the framing range. Create a name just for shader name here. Create the node flag. Let's see the final result with the metal support here. Let's create. Actually, we are going to do that. Here we can create a checkpoint. No in. And use the checkpoint just to reference here down of the network. The cloth. Without the metal support, without the original flag. Let's create a blast. Keep metal support. Here the group, remove the flag, keep the metal support, and merge. Create another name here for the metal. Change to metal. Actually, we don't need because we already have the name attribute here, the metal. Create a checkpoint for the simulation. Alt flag. And change the color to black. That's the result of the simulation. Let's create a flipbook here and see. That's the final result of the simulation with the tearing pieces and the spreading fire attributes attached to the cloth. Now we are going to create the Pyro simulation for the spreading fire here. Let's go up there and create another geometry node. Change the color to green. Rename to flag, fire. We can hide these nodes here and enter. Let's dive inside the flag fire. Let's create object merge. Let's create an object merge. Let's grab our alt flag geometry. Let's create a blast. We just need the cloth simulation. We don't need the support. Keep flag. Let's check what is happening here. Let's go there. Actually, we need this. We needed this geometry here in the Pyro simulation. Let's create a checkpoint here. Ref, Vellum, stitch, attribute, ref flag, stitch attribute. Let's go inside the flag. Let's change the path here to Vellum, flag stitch attribute. We just need that. Let's delete this blast. We don't need this blast. Create a scatter points. We just need the scatter points at the color areas here, the spreading fire areas. Okay, let's change the background to dark gray to see better. At the scatter points, we can increase this to 3000. We can disable randomize order. And that's it. Let's create a Pyro source. We should be enable the source burn and source smoke to activate the density. At the particle separation, we can decrease to 0.01. Create some attribute noise here, just to make a variation in the density, burn, and temperature. At the first, we can create a noise in the density attribute. Should be float, multiply, disable output raw value. At the density, enable remap ramp, and move this a little bit here. And the element size decrease to 0.2. Create another mountain, another noise, noise attribute. Change the value to burn. Float here. The operation should be multiplying. Disable output raw value. Enable remap ramp. Move here a little bit. And the element size should be 0.3 and offset like 20. Create another noise attribute for the temperature. Temperature should be float, multiply, disable output raw value, and enable remap ramp around this. The element size should be 0.25 and offset 10. Now let's create a rasterize attributes for create this, convert these three attributes from the points for VDB. Here, activate the burn, the density, and the temperature. We need to decrease the voxel scale like the same value of the particle separations of the Pyro. Let's copy this parameter here and paste this parameter here. Paste relative reference. And you can increase the resolution of our voxel here. We need to create too a velocity. For this, we need to compute velocity, create a trail, compute velocity of the flag before the scatter points, rename this to compute velocity, change here to compute velocity and evaluate with frame range. Okay, let's create add node, connect to the compute velocity, and delete the geometry but keep the points. Create an attribute create, change the name to p-scale, and change the value to 0.1. You can rasterize this node too. Rasterize attributes to convert these velocity points for VDB. Attribute change to V. Copy the particle separation of the Pyro source and paste here. We don't need to small value, we can multiply this by 2. We don't need so much resolution in the velocity. Let's merge these two rasterized nodes. This is for density, temperature, and burn, and this is for velocity. Let's create a Pyro source. Pyro solver, sorry. Create a cache, file cache. Rename this to cache. Flag, fire, and create a checkpoint here. Sorry, not the node. Checkpoint, null. Alt fire. Change the color to black. Let's organize our network. Okay. And change some parameters here in the Pyro solver. First, we need to copy the particle separation for the Pyro source and apply here to the Pyro solver as well. We can scale the value just for visualization for tester simulations by 2. Increase the minimum steps by 3 and the maximum steps by 3 as well. In the sourcing, let's increase the burn to flame by 2. At the fields, in the flame, decrease lifespan by 0.3. Change the shape here. Decrease the buoyancy by 0.2. We don't need the fire going up so fast. And enable the shredding. Here in the output, we can disable the color, and we need to convert all these fields to VDB and use 16-bit float to compress the cache files. Let's see what is happening in our simulation. Our simulation was cached. Let's change in here in the flag to UV quick shade just to preview the texture, the skeleton texture here, and see if they bake the simulation, the cache simulation of the fire. Let's see the cache. That's the result of our cache fire and the flag simulation, which is really cool. Now let's start with the rendering in Karma Solaris. Let's create a loop network. Let's rename this to lookdev flag. Let's dive inside this node. Create a SOP import. Rename this to flag. Copy this node and paste here and rename this to fire. Let's merge both of these nodes. Let's find our flag here, out flag. Change here to sublayer style to cop SOP. Do the same here. And find the fire, out fire. Okay. Let's create a material network, material library. Create a material assign. Let's create a camera. Let's position our camera here. The cool position, like this position here is cool. Okay. Let's create a dome light. Find our ADR file, like this one. Create a Karma node. Rename the Karma to flag, beauty, flag beauty. Change some parameters here in the Karma. First, enable XPU if you have a good graphics card. Change the resolution to 9020. Decrease the path tracing to a small value just for test renders. Camera effects, you can disable depth of field and let the motion blur enable. Okay. Let's create our shaders here. Karma, material builder for the cloth, for the cloth. Karma, flag. Create another karma for the metal support here. Karma metal, and create a karma pyro material. Actually, you can create a karma pyro fire material here. Rename it to karma fire. Let's go outside this node, autofill materials, and apply the for each object here. We need 3 objects. Let's find here. First for the fire, with the fire material. Second for the flag, with the flag material. And third one for the metal, with the metal material. Let's dive inside the material library for the flag and load our texture here. Image. Connect the image to the base color of the standard shader. This is our texturing. Okay. Let's decrease, change the roughness. I think like 0.3. 0.3. Let's create a bump map to make the pattern of fabric pattern in the cloth. Connect this. Actually, you can connect this to displacement. Create another image. Our texture fabric file is like this. This is our skeleton texture. This is our bumpy flag. Let's load the fabric file here. Connect to displacement and decrease the scale like 0.01. At the metal, we can actually, let's see the render right now. What is the look of the render? The fire have low intensity. We need to increase the fire intensity and apply the shaders to the metal support. Let's change the value here. Let's change the metalness. Decrease the base height here. I think it's good enough. Let's decrease the intensity of the displacement here. I think the displacement of the flag is too high. Let's decrease this a little bit, like 0.02. That's enough. 0.5 is enough, I think. And increase the roughness a little bit. It's too wet, like 0.6. I think it's working. Let's go back to the camera position here and see the shaders of the fire. Adjust the shader of the fire. Let's increase the density of the smoke by 10. Okay. For the fire, we need to increase the intensity of the fire like 100. Too much. But you can use masking here, enable mask. And here in the binds, we can change the intensity volume for the flame field instead of temperature. Because if you are going to use temperature evolves like all the density, all the information. We don't need fire in these areas here. We can reduce just for the flame field. And the fire should be applied in different areas. Going back to fire, we can adjust the mask. Like this. Increase the intensity of scale, fire scale by 400. Let's adjust the ramp here. Like this. Can add a point here, the curve. It's looking great. Let's see another frame. It's looking cool. Let's see the final result of the render that I did. That's the final result of the render that I did before. If you want, for example, increase the details of the fire, at your simulation here, you can increase the voxel resolution here. You're going back to the fire, increase the resolution of the Pyro solver here. You can just multiply by 1 or by 0.5. 0.5 take too much memory in the machine. You can multiply by 1 and increase the voxel quality of your simulation. That's it, guys. That's the final result of our part flag of a burning flag. Thanks for watching. See you at the next video.